Hi everyone, welcome to Fun Chemistry at Home. This is the fifth webinar series for STEM for Humanity, our organization. First, let's do like a quick overview of the topics that we'll be covering today. So first we'll be doing a quick introduction of our presenters today, and then I'll be presenting an experiment on frying an egg. Kaden will be presenting an egg in vinegar experiment, Cecilia baking soda volcano, Jenny, elephant's toothpaste, and Benjamin will be presenting hot and sour shredded potatoes. As a quick introduction, we're just going to go around the speakers and introduce ourselves. So my name is Emily. I'm president of Youth STEM for Humanity Coalition, and I'm a freshman at Brown.
I'm Kaden, and I'm an 11th grader at Diamond Bar High School, and I'm the director of coding for STEM.
Hi, I'm Cecilia, and I'm the director for Biomed for Humanity, and I'm a junior at Diamond Bar High School.
Hi, I'm Jenny. I'm Assistant Director of Biomed for Humanity. I'm a junior at Westlake High School.
Hi, my name is Junjie, also called Benjamin. So my position is Assistant Director, Math for Humanities Circle and Youth STEAM for Humanity Coalition. I'm 10th grader in Diamond Bar High School.
We are the speakers that will be presenting this webinar today. A lot of us in the meeting today are also part of this organization. So we are Youth STEM for Humanity Coalition, and we're a global student organization dedicated to bridging STEM and society, as well as cultivating creativity and compassion in future leaders. So one of our missions is to bring together passionate individuals that are dedicated to using our STEM skills and knowledge for positive societal impact. And our board members are enthusiastic about organizing events and driving positive, meaningful change in our communities. And if you're interested in making a difference in your local community and in the international community, you can feel free to apply to join our student board and help drive those positive changes in our society. So if you're interested, feel free to check out our website, www.youthstemforhumanity.org, or you can send us an email to coordinate becoming involved. I'll be explaining the chemistry behind frying an egg. So first off, some materials, of course, you would need an egg, which is the main ingredient. Cooking oil or butter, this is to prevent sticking. It also conducts heat evenly and adds flavor. You also need a frying pan, spatula, stove, a bowl, and a plate. Frying an egg is pretty simple. So you put the frying pan on the stove over medium heat, add some cooking oil or butter, and you crack the egg into a bowl or directly into the pan. Then you cook the egg by letting it fry until the white is set and the edges are crispy. And then you can use a spatula to flip the egg or transfer it to a plate. Hey everyone, I'm Emily, and today I'll be showing you the chemistry behind frying an egg. So first off, here are some ingredients that we need. Oil, and an egg, and a frying pan. And here's the egg when I crack it into a bowl before I put it into the pan. So notice how there's two distinct sections, the egg white and the egg yolk. Before I add in the egg, I added in some oil into the frying pan. And the purpose of the oil is to act as a heat conductor so that the heat can spread evenly throughout the pan so that the egg doesn't have parts of it being burnt. So now I'm adding the cracked egg into the frying pan, and as the egg hits the hot oil in the pan, the proteins and the egg white will first start to denature. Denature means that the proteins in the egg white will start to unfold and lose their original shape. Then those proteins that are now unfolded will start to coagulate, meaning that they will bond together, and this will form a solid network. So this is why the egg, notice how the egg white is changing from having a clear and runny consistency to being more opaque and more of a firm solid. There's a similar process going on for the yolk, but because the yolk has more fat compared to the white section of the egg, it tends to thicken rather than solidify completely. So this is why the yolk will have more of a creamy consistency after it's fried. We can also observe that a chemical reaction is occurring by observing the color change. So as the egg gets continuously fried, it becomes a golden or brown color. So this is our beautiful and very delicious fried egg. Thank you. That video went into a bit about the procedure as well as some of the chemistry behind it, but now I'll be explaining a bit more in depth about the exact chemical processes that are going on. The first observation is something called denaturation. Denaturation occurs as soon as we put the egg inside the frying pan. The heat will cause the proteins in the egg white, which is called the albumin, and the yolk to denature, meaning that the proteins will start to lose their 3D structure that gives them their function. One common theme in biology is that for proteins, their function is determined by their 3D structure. As the heat starts to denature the egg, the proteins also start to unravel. The egg will change from a liquid to a solid state as the denatured proteins form new bonds with each other, creating a firm texture. So essentially, initially you have the proteins losing their shape, but then as the proteins lose their shape, new interactions will start to form. And those new interactions will allow the egg to solidify into a solid state. Okay, so denaturation is a process where the protein's 3D structure unfolds and it loses its original shape. For the structure of proteins, so proteins are actually made up of long chains of amino acids that are folded into specific shapes. For protein structure, there's actually 4 levels of protein structure. One of those levels is determined by the sequence of amino acids that are joined together. Once those amino acids are joined together, they will then form bonds with each other, and that determines the next level of protein structure. For each consecutive level, there's new bonds being formed. What denaturation targets is the third out of the 4 levels of protein structure, and the third level, called the tertiary structure, is usually what determines the function of the protein. Yeah, so heat will disrupt the weak bonds, such as the hydrogen bonds, the ionic bonds, and the disulfide bridges that hold these structures together. And this is what causes the proteins to unfold. Hydrogen bonds are interactions between an hydrogen atom and a very electronegative atom, such as nitrogen, oxygen, or fluorine. All amino acids have an amino group, so they do have nitrogen. So there's going to be a bond between the hydrogen and the nitrogen. Ionic bonds will form between different charged ions, and disulfide bridges will occur between the sulfurs within the amino acids. Yeah, so the function of heat is to just disrupt those weak bonds in the egg that hold the structures together. In the beginning, you have this protein that is fairly organized, so there's like different regions. These looped regions are called alpha helices, and then some of the straighter regions are called beta pleated sheets. After adding heat, denaturation will occur, and notice how all of those shapes are being disrupted. So we get this denatured protein without any sort of shape, and therefore it loses its function. So the next step is coagulation, when the egg white starts to change color. So the egg white will start to become opaque and firm, and the yolk will thicken. After denaturation, after the proteins unravel, the proteins will then coagulate, meaning that they will then form new bonds to form a solid network. How these bonds form is through hydrophobic interactions. Hydrophobic regions are the water repelling regions of the proteins. So there are certain amino acids that are more hydrophobic than others, and some of those amino acids will be exposed, and that will cause those amino acids to clump together. And since amino acids are part of the protein, then different sections of the protein will then clump together and trap water, fats, and other molecules inside the clumps. And then the third reaction is the Maillard reaction, which is the browning reaction that occurs on the surface of the egg. And this is what actually gives the fried egg its golden color and a richer flavor. A Maillard reaction is where the amino acids from proteins and reducing sugars, which are in the egg, at high temperatures will then react. In this case, the high temperatures of the stove and the fire will cause the production of heat, and heat serves as a catalyst to help speed this reaction up. Without the presence of heat, if you just have an egg in oil, nothing's going to happen. But heat helps to serve as a catalyst to help speed up this browning process of the egg. This also produces new flavor compounds and brown pigments. It occurs in these stages. So here, this is the sugar. The sugars are usually present in the egg in the form of glucose. You also have an amino group, which is NH2, and together they form this new compound as well as water. Parts of it will decompose into this compound and so on. So notice how in the end, if you fuse this compound, you will eventually get this compound, which actually serves as a chemical that produces an odor. It produces the flavor and the smell that's associated with a fried egg. If oil or butter is used for frying, the fats can undergo oxidation when exposed to heat. The fats may develop a slightly nutty or toasted flavor, therefore enhancing the taste of the fried egg. The purpose of oil or butter, not only does it serve to increase the surface area so that parts of the egg don't get burnt, it's also for causing this oxidation reaction that can cause new aromatic compounds to be synthesized in this process. For oxidation of fats, this is when heat breaks down the fat molecules, causing them to react with oxygen in the air, and this can produce new compounds, some of which contribute to flavor. Yeah, so if you cook the egg too long, then parts of it will become burnt. And that's essentially when the proteins are already being denatured. When the yolk starts to spread throughout the pan, that is when the egg denatures. If you cook the egg too long, then even more parts of it will denature, and there is also new compounds being synthesized. And the process of oxidation will help to change the color of the proteins to a slightly darker color. For example, parts of the egg might turn black. It's oxidation and denaturation combined. As a summary, so there's the denaturation phase, coagulation, the Maillard reaction, and the oxidation of fats. And for some applications of frying an egg, the Maillard reaction doesn't just give fried eggs their golden color and rich flavor, but it's also used for baking, roasting, and grilling. So this is why after you bake bread, there might be an aromatic scent coming from the oven, and that's because of the Maillard reaction. Also, allergen management in healthcare, so heat can alter the structure of proteins, potentially reducing their allergenicity. The reason why allergies occur is because of antigens that are released by the thing that causes the allergy. So for example, like if you're allergic to the pollen, then the pollen serves as an antigen, and the antigens will then become recognized by parts of your immune system, and that will cause an inflammatory response that is associated with the symptoms of an allergy. So if heat can denature proteins, they can also denature those antigens that cause the symptoms associated with an allergy. Also, food preservation, so the principles of protein denaturation and coagulation are also used in processes such as pasteurization and sterilization to extend the shelf life of foods.
I'm Kaden, and I will be doing this egg and vinegar presentation. And for all you need for this experiment is an egg, some white vinegar, and a cup to put that in. So what you gotta do, you gotta take out the cup, put the egg into the cup, and pour some vinegar into the cup until it covers the egg. And you're just gonna wait about 24 hours for everything to fully happen.
Hello, I'm Kaden, and I did the egg and vinegar experiment. And all you need for this experiment is some vinegar, an egg, and a cup. And to do this experiment, all you have to do is put the egg and vinegar into the cup and wait until the vinegar reacts with the eggshell. This egg was in here for about 24 hours, and as you can see, the eggshell is almost completely gone, which just leaves the membrane of the egg, and now I can just bounce it.
Alright, so this is the egg after 48 hours of being in the vinegar. As you can see, unlike the video, it's much more clear and less white. And now all of the eggshell is gone, leaving you with just a bouncy ball.
And what happened here is that an acid-base reaction between the acetic acid in the vinegar and the calcium shell.
Why this happens is because the vinegar has acetic acid, which starts to dissolve with the calcium eggshell in an acid-base reaction. And this reaction also forms carbon dioxide bubbles. Yeah, that was just a pretty simple experiment to show how acid can really dissolve things like calcium. And just to have another thing to say, when you drink soda, a lot of soda has acid in it, and teeth have calcium, much like that eggshell. What do you think this means? So this just means that there's a reason why everyone says that soda is bad for your teeth.
Hi, I'm Cecilia, and I'm presenting the baking soda volcano. So the materials that you'll need are very simple. All you need is baking soda and vinegar, and if you want, you could add some red food coloring to make it look like a real volcano. So all you're gonna do is add baking soda to a container and then add vinegar to the container. You could also add red food coloring to the vinegar to make it look real.
Hi everyone, I'm going to be using baking soda and vinegar to demonstrate an acid-base reaction. First, I'm going to be adding this baking soda to this clear container. As you can see, this baking soda covers the bottom of the container. Next, I'm going to add this vinegar into the container with the baking soda to start the reaction. The baking soda is mixed with vinegar and a chemical reaction occurs between them. The vinegar, also known as acetic acid, is a weak acid, and baking soda, also known as sodium bicarbonate, is a weak base. When these two substances react, it produces carbon dioxide, water, and sodium acetate. The rapid release of carbon dioxide gas results in the bubbling effect. This is because the gas expands quickly and escapes the liquid mixture.
So the reason why this happens is when we mix the reactants, baking soda and vinegar, a chemical reaction occurs between sodium bicarbonate and acetic acid, and the reaction produces carbon dioxide gas, water, and sodium acetate. And the carbon dioxide gas is what creates the bubbling and fizzing effect. The rapid release of carbon dioxide gas results in the bubbling and frothing, mimicking a volcanic eruption, and this is because the gas expands quickly and escapes the liquid mixture. On the right side, you can see the chemical equation. Some applications of this is volcanic eruptions, as it mimics real volcanic eruptions where gas buildup in magma creates pressure and eventually causes an explosion. And cooking, baking soda reacts with vinegar to produce carbon dioxide, which helps dough rise through alcoholic fermentation. And this could also be used in cleaning applications, as the reaction between baking soda and vinegar helps remove stains, break down grease, and unclog drains. And it is a natural cleaning solution instead of using harsh chemicals.
Hello everyone, my name is Jenny, and I'll be introducing the elephant's toothpaste experiment today. So here are the materials we need for this experiment. I've used the 3% H2O2, the hydrogen peroxide solution, which is just the most common one we've always been using. Also the dry yeast, the dish soap, warm water, test tube, and beakers and transfer pipette. Here are the steps to do the elephant toothpaste experiment. First, I pour the hydrogen peroxide. The first step is to just get all the materials prepared, and then I pour the hydrogen peroxide solution into the test tube, then add the dish soap and swirl to mix. It's better to actually use the warm water at that point to heat the hydrogen peroxide a little bit to make the reaction more obvious. Then I mix the yeast with warm water in a small cup and stir for 30 seconds to just activate the dry yeast. Then quickly pour the yeast mixture into the test tube. Then we can see the foam expand, just like the toothpaste foam. Hello everyone, today I'm going to make the elephant toothpaste. Here are the materials we need: the liquid dish soap, beakers, dry yeast, and the 3% hydrogen peroxide. I also have some warm water in the foam cup. Now I squeeze the soap into the beaker. I poured the hydrogen peroxide into the beaker and then into the test tube. Then I put the hydrogen peroxide solution into the warm water to heat it up. Now I'm adding the dish soap into the test tube. I put some dry yeast into the beaker. I use the pipette to draw up the warm water and squeeze it into the beaker. Let the warm water and yeast mix for a while to activate the yeast. Add this solution to the prepared test tube. The yeast contains catalyst, that is an enzyme that speeds up the reaction. The oxygen gas released gets trapped in the dish soap, creating a massive amount of bubbles. Thanks for watching. And now here are more explanation why that would happen. So for the hydrogen peroxide, it naturally decomposes into water and oxygen gas, which can be written into a chemical equation that is 2H2O2 as reactant produces H2O and oxygen gas. The decomposition of hydrogen peroxide reaction happens slowly, naturally, because the molecules need extra energy to break apart. Reason why we're using yeast in this experiment is that the yeast contains an enzyme catalyst, which acts as a catalyst in the reaction to help produce the oxygen gas rapidly and creates bubbles in the dish soap. Also, the oxygen gas get trapped in the dish soap. This reaction, generally speaking, is a exothermic reaction, which means that it releases heat as the foam is forming. And when I was doing it, I can feel that the foam came to my finger and it contains heat. To apply this elephant's toothpaste in our real life is that the hydrogen peroxide is what we use to kill the bacteria and clean our wounds when we somehow get injured. And as the reaction going, it creates oxygen bubbles, and the oxygen bubbles help remove dirt and debris. Also, in the as like using as toothpaste or dental care is that when we are using our toothpaste, which the toothpaste also contains the hydrogen peroxide, and that can break down those things and kill the bacteria in our mouth. Also, the yeast, which I used as catalyst in this experiment, can also be used in making bread, but in the bread making, it produces carbon dioxide instead of, in this case, we produce the oxygen gas.
Hello everyone, today I'm going to introduce you to my delicious and simple dish, the hot and sour shredded potatoes. This dish is a classic in Chinese food, and I will explain the chemistry behind it. Before we start cooking, let's go over the ingredients and the tools we'll need. Like the main ingredients is the potatoes, and for additional ingredients are dried chilled peppers, garlic, white vinegar, salt, light soy sauce, sugar, cooking oil, and the tools we needed is grater, knife, cutting board, and wok. And let's see the step for making this dish. So for potato preparer, peel the potatoes and grate them into thin strips using a grater. Rain with water to remove surface starch to prevent stinking. Soak in water for 10 to 15 minutes, then drain and set aside. Preparing other ingredients. Cut dried chili peppers into small pieces. Slice garlic. Last big step is stir frying process. Heat oil in a wok and add chili peppers and garlic, stirring until fragrant. Add the drained potatoes and stir fry for 1 to 2 minutes on high heat. Add vinegar and continue to stir evenly. Add salt, soy sauce, and add a little sugar. Stir fry until the potatoes are cooked but still crispy. Turn off the heat and serve immediately. Hello, today we are making a delicious and scientific dish, hot and sour shredded potatoes. First, we start by peeling the potatoes and shredding them into thin. Then, we rinse the peeled potatoes. This is our slicer, and we are going to rub the potato back and forth on it, and we are going to turn the potato into a shredded shape. We put the sliced potato strip into a bowl, rinse them with water. The purpose is to quickly remove surface starch. Using your hands to mix the potatoes while rinsing helps remove the starch more effectively. Then we fill the bowl with water and soak for 10 to 15 minutes to remove starch and prevent stinking. After soaking, we drain the water. Now, let's start cooking this dish. These are dried chili peppers and garlic, which we will use to add flavor. And we will also use these ingredients in order they call vinegar, soy sauce, cooking oil, salt, and sugar. Heat a little oil in the wok, add the dried chilies and garlic, cooking them on low heat until they smell good. Now, add the potatoes. Stir them quickly on high heat for 1 to 2 minutes to keep them crunchy. Adding vinegar made the dish more tangy. First, add light soy sauce. After adding soy sauce, continue stirring evenly. Next, a little sugar balances the flavors. Finally, add salt and mix well. After 3 to 5 minutes, the potatoes should be cooked but still crispy. cooking too long makes them soft. Now transfer the potatoes to a plate. Your hot and sour shredded potatoes are ready to enjoy. The experimental principle. The first one is starch removal. Soaking potatoes removes excess starch, keeping them from sticking and making them crispier. Number 2, preventing browning. Soaking stops oxidation, so the potatoes stay fresh and white. 3, acid-base reaction. Vinegar's acetic acid reacts with carbonates, creating tiny CO2 bubbles. The experimental application. The first one is food science, which may explain starch oxidation and acid-base reaction in cooking. The second one is cooking tips, helping keep potatoes crispy and prevent them from sticking. The last one is health benefit. Vinegar helps absorb calcium and chili boosts appetite. Let's take a moment to summarize the key scientific principle for making this dish. So the first one is starch removal. Soaking potatoes remove excess starch, preventing sticking and ensuring crispiness. Preventing browning. Soaking slows oxidation, keeping potatoes from turning brown. Acid-base reaction. Vinegar may react with pan compounds, creating small carbon dioxide bubbles. And the last one is application. So the food science and cooking technicals. Heating the starch in potatoes helps them stay crispy while stir-frying, instead of turning soft and mushy. Maillard reaction enhances flavor and color when stir-frying at high temperature. Nutritional benefit. Vinegar aids calcium absorption and digestion. Chili peppers boost metabolism through spicy compounds, which triggers a heat response.
And yeah, that's all for our experiments that our presenters wonderfully presented. Big thank you to the presenters and thank you to all of you guys, the audience members, for attending this webinar. And if you guys are interested in more webinars in the future, you can check out our website or you can send us an email if you're interested in getting involved. Thank you guys for attending and have an amazing week. Bye.